Good morning, my YouTube viewers. It is Crystal here, and I just wanted to give you another code review. This code review is a Kaggle competition, minimum census income, and basically it was with a community competition, and so I entered the community competition, and what I will do is I will leave a link to the Jupyter notebook that I wrote in the description box down below, and so that will enable you to look at the code if you want to look at the code. There was actually a problem with the competition because all of the scores came out as being 0. So, and it wasn't just me, it was other people who entered the competition as well. So I'm not sure exactly what the problem was, but I did leave a note in the discussion saying that maybe there was a problem with the scoring because everybody's getting 0. But nevertheless, I'm going to go ahead and give you the code review for this competition. So I created the program in Kaggle's free online Jupyter notebook, and that is stored in my account. But I will give you a link to the Jupyter notebook so you can look at it if you want. And then after we created the Jupyter notebook, you want to look at the problem statement. The problem statement is classify whether a person has an income higher than $50K a year or not based on 41 features. So that means you have 41 features that you have to predict on. And so after we have read our problem statement, what we want to do is we want to import the libraries that we're going to use in this program. So we're going to import NumPy as MP, and so what that does is that creates NumPy arrays and also performs numerical computations. We're going to import pandas as PD, and that creates data frames and it processes the data. We're going to import OS, which goes into the operating system and retrieves the files. We're going to import sklearn, which provides machine learning functionality. We're going to import TensorFlow, which creates the neural network. And we're going to import matplotlib.pyplot_splt, which visualizes the data. And we're going to import Seaborn as SNS, which also visualizes the data statistically. So after we've imported the libraries that we're going to need to run this program, what we're going to do is we're going to use the OS library to go into the operating system and retrieve the files. And the 3 files that came up were the train, test, and sample submission CSV files. So after we have retrieved those files, what we're going to use is we're going to use pandas to read the files and convert them to data frames. And the 3 data frames that I've created are train, test, and submission. So since we have 41 features that we're going to have to make predictions on, I set the pandas display up so to show maximum columns. So that's pd.setOption display.maxColumns, none. And so you can see all the columns here. And it's 41 columns and a lot of information to go over, a lot of information to cover. And at the very end, it tells you whether they're less than $50,000 a year or more than $50,000 a year. So we check information, info, train info, and you can see you've got integers, floats, and objects. Okay, so we've got this unknown, which was a float. I'm not sure exactly what unknown is for, but you've got it in there. And then what we want to do is we want to check for null values. and there are 8 columns of data that have null values that we have to do something with it. And then we check the test file. The test file is the same as the train file, except for the fact it doesn't have the salary. And then we check for any null values. You see we have 8 columns with null values as well. So, and then we check our submission. And this is what Kaggle wants to see when we submit our work. So, what we're going to do now is we're going to remove all the columns that have missing values, because there's 41 columns. It's a lot of columns to go over. So to drop equals a blank array or blank list. For call and train, if train call.isNeg.sum is greater than 0, to drop append call. And then so we had the 8 columns that had missing values. So we dropped those columns from both the train set and the test set. So train.drop, to drop, axis equals 1, in place equals true. So now you see we only have 35 columns of data instead of 41 or 41 columns of data. So now we check for null values again. And you can see that there's no more null values. Or maybe it was 6 columns of data that had null values. I thought it was 8, but maybe it was only 6. So now we check test to see if there's any null values, and there's no null values in test. So now what we're going to do is we're going to analyze train. And what we want to do is we want to look for all the unique values in train. So you can see you've got all the unique values if it's an object. There was no point checking for unique values if it was an integer or if it was a float, but we want to check the unique values in object. And now what we're going to do is we're going to analyze train, but the first thing we have to do is we've got a blank space on the left side of income is 50K. So train income 50K equals train income 50K dot str dot lstrip, and that strips the space off of the left hand side of 50K. So target equals train.pop income 50K, and what we're doing now is we're defining the target, and we take the income 50K off of the train file, and then we set it up for use Seaborn to create a histogram. And so you see that we've got a lot of people under 50K and not very many people over 50K. And then what we want to do is we want to check to see if the train and the test sets columns are from the same distribution, and we use SciPy stats to do that. And in this particular data set, all of the features are from the same distribution, so we don't have anything to drop. And now what we want to do is we want to remove all of the white space from the train and the test file. So for call and train, if train call.dtype equals object, train.replace white space with nothing, and test.replace white space with nothing. So now what we're going to do is we're going to replace the numbers neg 50,000 and plus 50,000 with 0 and 1. So if it's neg 50,000, it's going to be 0, and if it's plus 50,000, it's going to be 1. And what they had done was they had 1 plus 50,000 with a full stop on it, so we had to make that 1 as well. So now you've got, instead of neg 50,000 and plus 50,000, you've got zeros and ones. So we do a value counts on the target, and you've got 149,712 zeros and 99,906 ones. So now what we want to do is we want to encode all of the object columns, because the model is not going to make predictions on object columns. So from sklearn.preprocessing import labeling ordinal encoder, enc equals ordinal encoder for call and train. If train call.dtype equals object, train call equals enc.fit transform, train call.values.reshape -1 1, and then test call equals nc.transform, test call.values.reshape -1 1. So you can see we look at train, and now it's all numeric values, which is what they want. I also created a heat map because we wanted to see how highly correlated the columns of information are. So there's your heat map. And then so you do have this group here that's highly correlated. So we look at core, so you can see core, and if you want to look to see how highly correlated all of the columns of data are, you can see that here under core. And now what we're going to do is we're going to put code in to remove all of the columns of data that are highly correlated. But the first thing that we have to do is we have to identify them. So we had one column of data that was highly correlated. It was called det HH sum. And then so we removed that column from both the train data set and the test data set. And now what we want to do is we want to standardize our data. And so I decided to use sklearn's standard scalar. And the reason why I decided to use that is because if I standardize the train and the test separately, I wasn't really sure if there were going to be errors, how good that was going to turn out. So rather than standardizing the train and the test separately, I use sklearn's standard scalar to do that. So from sklearn.preprocessing import standard scalar, scalar equals standard scalar for call and train. Train call equals scalar.fit transform, train call.values.reshape -1 1, test call equals scalar.transform, test call.values.reshape -1 1. So now you can see, we look at the train file, and we can see all of our columns of data are standardized. And now what we're going to do is we're going to define our x and our y variables. Your y variable is dependent, and it is the target, and your x variable is independent, and it is train, and x test is test. We're going to use sklearn's train test split function to split the data set into training and validation sets. And then so you can also check the shape. So now we only have 33 columns of data. We went from 33 columns of data, we went from 41 columns of data to 33. So that means that so far we removed 8 columns of data. So now we're in TensorFlow. So what we want to do is we want to import TensorFlow and its associated modules or functions. You can see that we're using version 2.12 TensorFlow. And now what we do is we create our neural network. It's a sequential neural network, and we name it 50K salary. So we have our input layer, which takes the xtrain.shape1 as your number of columns for input, and we call it the name equals input. Then we have a dense layer of 50 neurons. Activation equals reclu, name equals layer 1. We have dropout model. We have another dense layer of 15 neurons. Activation equals swish. Name equals layer 2. We have another dropout model, and then we have the final layer, which is a dense layer of 1. Activation equals sigmoid. Name equals output. And then we give you a summary. So you've got a summary of that. Now what we do is we compile our model. So loss is binary cross entropy, optimizer is atom, and metrics is accuracy. Then we define our callbacks. We set epochs equals 50, and then we train the model. History equals model.fit, xtrain, ytrain, epochs equals epochs. Validation data equals xval, yval. Verbose equals 1. Callbacks equals my callbacks. And then so it trains the model, and it stops at 14. And now what I do is I created a little graph so you can see the loss and the accuracy. So the loss is pretty low, and the accuracy is like 94, 95%, and it's a straight line. So now what we do is we evaluate the validation set, and you can see that the accuracy of the validation set is 0.9505. So we're going to make predictions on the validation set, and then you see that we've got our predictions here. I created a disk plot of the predictions so you can see what those predictions are. I checked the score. The score was 9505. We checked the confusion matrix. So the confusion matrix tells you how many are correct and how many are incorrect. And so when I think about it, upon reflection, one thing that I could do to possibly improve the score would be to set it up for balance. Check your balance and class weights. So I could balance my class weights and see if the score improves if I balance my class weights. So I think that's going to be one thing I'm going to do when I finish this code review, is to try to balance the class weights and see if that improves my score. Then we're going to predict on the test set. And then we've also got a histogram of the prediction. So that looks okay. And then we prepare our submission. Submission income 50K equals predictions. We're going to convert it to a CSV file, and then we're going to read the CSV file, and then you're going to into a data frame, and then that's what we've got. And so basically, there was definitely something wrong with the competition because I submitted my work twice, and twice I've got a 0, and it's not 0 on the program, so it means that there's something wrong with the competition. But one thing that I will do is I'm going to go ahead and try to balance my class weights and see if that improves my predictions if I balance my class weights. So thank you so much for watching this video. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make a new video, please tap onto the bell button next to the subscribe button. And thank you to my subscribers for supporting my channel. And thank you for watching my video again. I look forward to making more videos for you in the future.